Okay, some viruses like to make it hard for antiviruses to detect them by using different ways and techniques to hide in an infected system. And we'll define the most common ways here.
Right. And first up, read request intercepts. Antivirus sends a read request to the OS in order for it to scan it. And some viruses, in essence, trick the antivirus by intercepting this request and returning an uninfected version of the desired file. It lies, basically. So the interception occurs by code injection to OS files that handle read requests. The antivirus may receive an answer that the file is clean or cannot read the file, thus the virus stays undetected, right? Now, to fight back this virus, the best way is to use an integrity checker or replace the OS's infected files or to scan the volume with perhaps another known clean machine.
That's right. Yeah. Now, next we have self-modification. Antiviruses employ a technique called signatures. Now, the term is really misleading.
Yeah.
And to be more accurate, search strings is the right term. Viruses do not possess any signature that can identify them. Rather, there's a sequence of bytes that the antivirus is looking for. Now, when it's not found, the indication that the file might be infected, then the antivirus then employs other techniques to make sure that the suspected file is really infected. Now, if this sequence of bytes is changed, then this will indicate that the virus is different, or in some cases, that it's not a virus. Bottom line, this method is going to be used by viruses to modify what we know as signature. Okay, each time they infect a different file, which makes it really, really hard for antiviruses to detect all of them.
That's right. And another method of evading detection is by using encryption, as we know. Viruses encrypt their body and leave only the encrypted modules, which always remain the same. And then decryption keys in clear text. Now, this could be very complex, as viruses can encrypt each infected file with a separate key altogether, right? And that's a lot of them. Antiviruses cannot decrypt the files, but can suspect them and flag them for later investigation. Decrypting the files is not impossible. By any means. The encryption used is symmetric, and since the encryption keys are left on the machine in clear text, we can decrypt the virus and then, by definition, analyze it.
That's right. Polymorphic code uses the technique of encrypted viruses with one major difference. The decryption module is changed with every new infected file. So polymorphic viruses do not have really any part that remains the same. This requires a polymorphic code within the body of the virus itself, and what we call the mutation engine. So how do you defeat this? Well, simply by using emulation. You might know this technique as sandbox. You may have heard of that. So the virus is left free to run in a virtual environment. And again, like in the case of encrypted viruses, we can use the decryption key, which is going to be left in clear text, to decrypt the virus. Now, if the payload, after decryption, appears the same in all the decrypted files, then this means it's truly a virus.
That's right, yeah. And the metamorphic code engine allows the virus at that point to defeat emulation techniques. The virus rewrites itself every time a new executable file is infected. Metamorphic code is used by some viruses when they are about to infect new files, and the result is that the next generation will never look like the current generation. The mutated code will do exactly the same thing, but there's a bit of a change. The children's binary representation will typically be completely different from the parents, much like my son and myself in real life. Thank goodness for him, by the way. Yeah, this technique is weak against this technique is weak, however, against heuristic analysis. Antiviruses who employ this technique will execute the programming commands of the suspected file or script in a specialized virtualized environment, allowing it to simulate what would happen if the code was executed. If any suspicious activity is detected, the file is flagged as a potential virus, but no harm done.
That's right. No harm.